Okay, hey guys. This is going to be a pretty simple and short, quick video. We're just going to go ahead and go through Castle Unit 4 Worksheet 3 on color coding this capacitor charging. We're just going to go through it together. I know color coding is brand new. This is the worksheet that we're going to use to introduce color coding. Um, and I guess just to give you that sort of introduction to it real quick, we already know what voltage is, and we already know that it is essentially caused by the distribution of charge, and that a positive charge would want to move from high voltage to low voltage, and a negative charge or an electron would move from low voltage to high voltage. Now you'll have to bear with me here, as you see on this picture right here. You can see that the arrows here, oh boy, you can see that the arrows here and here, these arrows are pointing in the direction from positive around to negative, that a positive charge would be moving, but we actually know that electrons would be moving this way, from negative to positive. But that's okay. The color coding concept still makes sense. Voltage is still high where voltage is high. So here we go. I'll just read along with you and do this worksheet. Okay, so it wants us to color the battery, the wires, and the capacitor plates in these diagrams right here, as it says in these instructions. And this figure right here on the left shows a circuit that has a capacitor and two light bulbs. And since it has no battery, the original normal pressure or voltage in these wires, zero voltage if you will, hasn't been changed. And so we're going to color all of the wires and the capacitor plates yellow to show that that voltage in each of those wires is zero. It is the original normal yellow pressure. Now in the figure on the right, we have just put a battery into the circuit. And the positive terminal of the battery always has the highest electric pressure or the highest voltage. So we're going to color that red. And since it's just been connected, there hasn't actually been enough time for this, for any of the charge to move from here to here, right? Since the electrons would move backwards from this lower pressure or lower voltage at the yellow to the higher or red voltage. That's the direction the electrons would move. It hasn't really had time to move, and so the voltage there is still essentially zero. So we have a positive voltage right here and essentially zero voltage right here at the moment. Okay, so we're going to keep that yellow. Now I'm going to go ahead and scroll down here. The negative terminal of the battery is a place that keeps that side at a low electric pressure or a low voltage. So we're going to color that blue. And again, since there hasn't really been enough time at this point for the electrons to move from here to here, we're going to keep that wire yellow because there hasn't actually been enough time for charges to move. And so there hasn't been enough time for that to have anything other than a normal charge distribution. And so that wire there is still yellow, while this one here has a positive voltage. Or I'm sorry, that's my bad. This has a negative voltage and here has a zero voltage still. Okay, so because that light bulb resists movement of charge, as it says right here, because that light bulb resists the movement of charge, hardly any charge has moved out of the bottom capacitor plate, or rather, this talks about it moving the other direction. but charge hasn't had time to move, and so the electric pressure in that lower right wire hasn't had time to change yet. And we already know this. We already know that the pressure difference in those two wires that are connected to the bulb is what drives charge through the bulb. We already know that a difference in electric potential, or here it's called electric pressure, we already know that charge moves from an area of high pressure to low pressure, or electrons rather move from an area of low pressure or low potential up to higher potential. And it takes energy for that to happen, which is why the bulb lights up. It's essentially friction that is, see as it says here, it's essentially friction that causes that filament to glow. Okay, let's go ahead and keep going on here. This picture here shows this bulb on the left, and the battery's job is to make it so that this wire is always red and this wire is always blue. Remember, the purpose of the battery is to hold a constant voltage or a constant difference in potential. That way, charge moving through the circuit always gains the same amount of energy as it moves through that battery. But now we have had enough time for some charge to move from here over to here. And so as that charge has moved over, as those electrons have moved over, you see we've gotten a little bit of a positive charge there, as it says. And so this wire has gone up from yellow, and it's gotten closer to that higher voltage, that red voltage. And so we're going to call that orange. Whereas that wire down here on the bottom, kind of the opposite has happened. Electrons have moved from the first wire over to the next wire, and so you see that it's gotten more of a negative charge. And so we're going to call that one blue to say, or I'm sorry, green. We're going to call that one green to say that it is a lower voltage than yellow. So that's a negative voltage then, or below normal, below zero. Okay, and that red to orange pressure difference is less than the red to yellow pressure difference. So the voltage across this bulb here now is less than it was before, which is why the light gets dimmer. I suppose thinking about it now, it's actually been a little while since we've really used a lot of capacitors in your class. But remember, when we're charging a capacitor, we see that the bulb turns on, but then it gets dimmer. Okay, so that was what we saw with the charging capacitor circuit, is the bulb turns on, but then it gets dimmer until it goes out. So that's because this voltage difference right here around the bulb that I just circled, that voltage difference, the potential difference, is getting smaller as the voltage in this wire here, the orange wire, is getting higher. Okay, and that keeps getting higher until the voltage across the capacitor and the voltage across the battery are the same. So they both have this red to blue difference. And so because there is not a difference in pressure from here to here or from here to here, the charge stops flowing. Those electrons no longer move from side to side because they have that same pressure difference. Yeah. Okay, so just like it says here, we're noticing that there is no longer any pressure difference in the pair of wires connected to either bulb. And since we need that pressure difference to drive charge through the filaments, there is no further charge flow through the bulbs. The bulbs are not lit. The capacitor charging has stopped. Okay, so this has been an introduction to color coding using a charging capacitor. You're going to continue this introduction by looking at the discharging capacitor, which essentially is the same process but in reverse. So go ahead and go through Castle Unit 4 worksheet 4, which I've attached in the same assignment, and finish that off. And then go ahead and submit that work. If for some reason you don't have colors, you could use a number scale from 0 to 5, or I would use 1. How many colors did I just use? 5? From 1 to 5. So blue being 1 and red being 5. Okay, so if you need to use a color scale, you could go from blue, green, yellow, orange, and red. So if you don't have markers or colored pencils or something for some reason in your home, just go ahead and use numbers. Okay, from 1, 2, 3, 4, and 5. You can use numbers from 1 to 5 if for some reason you don't have colors. Okay, I guess that's good. Have a good rest of your day, guys. Bye.